We're going to look at example problems 67 and 68 together, found on page 114 of the textbook in chapter 6 on momentum. The questions are related, so we're looking at both of them together. Question 67 reads, a 1,200 kilogram car traveling north at 14 meters per second is rear-ended by a 2,000 kilogram truck traveling at 25 meters per second. What is the total momentum before and after the collision? So us to find momentum before and momentum after the collision. Remember, P prime means momentum after collision. What's given? Mass of the car is 1,200 kilograms. The mass of the truck is 2,000 kilograms. The velocity of the car, it is 14 meters per second to the north. Velocity of the truck is 25 meters per second. Okay, so it says the car is rear-ended by the truck. So if the car is moving this way, the truck rear-ends it. That means that the truck is also moving to the north. So their momentum, their velocities are in the same direction, so their momentums are in the same direction, so they're going to have an additive effect. They're going to add to each other, where if they collided and the cars are moving in opposite directions, the momentum before the collision would have a negating effect, right? It's because they'd have momentum in opposite directions. But because they're both moving in the same direction, the total momentum system, they can add together. So equations are relevant. Well, just mass equals momentum equals mass times velocity. So the momentum before the collision is equal to the mass of the car times the velocity of the car plus the mass of the truck times the velocity of the truck. Okay, so this equals 1,200 kilograms times 14 meters per second plus 2,000 kilograms times 25 meters per second. Okay, I'm going to say to the north is the positive direction, so they both have positive velocities. And so the total momentum equals 66,800 kilograms meters per second. Now it doesn't say that friction acts on them or no other forces act on the car and the truck. So if we're going to assume that the net external force on the system, which is the truck and the car, is 0, then momentum has to be conserved, and the total momentum after the collision will be the same. So momentum before the collision has to equal the momentum after the collision, because if we're assuming there's no net external forces, the only thing that exert forces on the car and the truck are the car and the truck. Car exerts a force on the truck exerts equal opposite force on the car. Then the total momentum before the collision and after the collision are equal, because momentum is conserved. That's 67. Question 68 asks, if the truck and the car, in exercise 67, lock bumpers and stick together, what is their speed immediately after the collision? Well, here we have the truck and then the car. That's before the collision. After the collision, you have these are terribly drawn. The car and the truck kind of stuck together, moving at some combined velocity. So the momentum here, before the collision, is equal to 66,800 kilograms per meter per second. The momentum here is the same, 66,800 kilograms meters per second. And so we can write the momentum here is equal to the mass of the car plus the mass of the truck times their combined velocity must equal this. Right? So solving for the velocity, the combined velocity, we have 66,800 kilograms meters per second divided by the mass of the car plus the mass of the truck. So that's 1,200 plus 2,000, so that's 3,200 kilograms. combined velocity comes out to be 20.875. Now, because it's more mass, well, sorry, this velocity should be in between the two. It should be faster than the car because now now it's the car and the truck moving together, so it should be some momentum should be transferred to the car, so the car should be moving a little faster, and some momentum was transferred from the truck to the car, so the car should be moving faster, but at the same time, the truck should be moving slower because it lost some momentum to the car. This is just in between the two. The total momentum in the system is the same. So the car, their combined velocity needs to be a little bit faster than the car was moving, but slower than the truck was moving. It can't be it can't be slower than the car, and it can't be faster than the truck before the collision. Especially because their momentum was in the same direction. So this answer makes complete sense.